Okay, so probably not all of this will display, but we'll take a look at some common objects that at least are on the screen. Okay, so first of all, the sun has an apparent magnitude of minus 27. So why is that such a large negative number? Can you tell me?
Well, it's because the sun's really bright and it's relatively close to us.
It's the brightest object that we have to reference.
Yeah.
Yeah, so because of that minus 2.5, brighter objects are going to be more and more negative. So the sun is really bright.
Yep.
And therefore it has a big negative intensity. What's the next brightest thing in the sky?
Usually the moon.
Probably the moon.
So here's the moon. It has a magnitude of minus 13. So, but you can see because it's a logarithmic scale, going from 13 to 27 is a huge change.
Yeah.
Right? But now maybe we can look at some of the reference objects. So Saturn and Vega. Do you know what Vega is?
Probably a star.
Yeah, it's a star that's near the North Pole, but not exactly near the North Pole.
What do you mean near the North Pole?
Like it's near Polaris, but it's in the other direction.
Okay.
I think it's the same position, but just the other way.
All right. So Saturn, and when it's in the sky, and the star Vega have a magnitude of 0. So there are reference objects for brightness. And then if we move towards brighter objects, Sirius, Mercury, Jupiter. The faintest objects visible to the naked eye when the sun is out, and then Venus has a magnitude of minus 5, and we can see it's actually 100 times larger.
Brighter.
In brightness. So the magnitude is minus 5. It's a change in 5 in the magnitude scale, and 100 times brighter.
Makes sense.
Why? Why does that make sense?
Well, we have log of 100 to the 1/5. So when you go 100 times, that 5 kind of makes sense.
Yep.
Yeah. Great. And we can see it even going up to 10, or down to magnitude minus 10. Here it's 1 times 10 to the 4th, so we get another factor of 100. So every 5 steps in magnitude changes by 100.
That's cool.
Yeah, that is pretty cool. And then going into fainter objects, maybe you know some of these. Antares. Have you ever heard of Antares?
I think that's another star.
Okay.
So I think it's a big star.
Polaris.
North Star.
All right. Do you know any of the names of any of these objects going down here?
See, well, Uranus.
Okay.
Bestia is another star.
All right.
Ceres and Neptune.
Ceres is a dwarf planet in the asteroid belt.
Okay. And then here's the star Proxima Centauri.
It's the nearest star to us.
Oh,
aside from
okay.
the sun.
And it's really faint, right? It's actually, it says typical limit of binoculars is magnitude 10. It's even fainter than that.
Yep.
So that's interesting. And if we just look over here, the faintest thing you can see with an 8 meter telescope, magnitude 27. The faintest thing you can see with Hubble, magnitude 32.
So this is basically just the faintest thing we can see.
Yeah, at least right now. So now let's go, now that we've seen some of the objects and understand their magnitudes, let's go back and I'll explain what the problem that Bruce McIntosh was explaining, and then we'll try to verify some of his calculations.
All right.